friends, welcome to the course on animation using Swing library in Java. Animation is related to the application programming of Java. Before going to discuss the application programming using Java, we want to discuss the basic concepts, the core concepts of Java. The course is divided into three modules. In module 1, we'll discuss the Java basics, the object-oriented properties, the three object-oriented properties of Java, which are encapsulation, inheritance, and polymorphism. We'll discuss in module 1, and in module 2, we will discuss the multitasking concept using thread class. And finally, in module 3, we will discuss how to build a GUI framework and how to implement animation using the Swing library. And in the entire course, I will show live programming so that it is easy to understand the programming concepts. The module 1 is devoted to the beginners, those who are very new to Java programming. In video 1, I will discuss introduction to Java, the basics of Java. Java is a general purpose, object-oriented, strongly typed, platform-independent programming language. I will explain each one. Now, Java is general purpose programming language. General purpose in the sense that Java has wide variety of applications. So Java can be used not only to solve computational problems, but also Java can be used for application programming also. For example, Java, in this course I will discuss animation. Animation is related to application programming. So Java can also be applied for animation type of programming to implement animation. Java can also be used for designing websites, dynamic websites, web pages rather, using applets. But current days, applet is not being used because due to development of some new languages like PHP, JavaScript, etc. So, but anyway, that variety of applications, application area is wide. The Java can be applied to wide variety of applications. Coming to the next point, object-oriented. Java is object-oriented programming language. Now, what is it? Object-oriented in the sense that a Java program, any Java program, is divided into one or several classes. At least one class should be there. So Java is class and object based. What is class now? I have said that only at least one class should be there in a Java program, and in a class the data, the variables, the functions means a module. This function is known as methods in Java. If we compare with C, the function in C is equivalent to methods in Java. The same thing, the name is different. Whatever the function is in C is same as is known as method in Java. Now you can see that in a particular class there can be several variables or several functions or methods. So now these methods or variables of the class can be accessed only by creating objects of the class. So class can be treated as a template or a blueprint containing the data and methods. But these data and methods cannot be directly, I will show in the next subsequent videos, I will show the implementation, then it will be more clearer. But just for the concept, we can see that class is nothing but a set of properties. Properties means data and functions, that is methods here. Class is a set of data and methods, and these data and methods can only be accessed by creating the object of the class, corresponding class. So the data and methods cannot be directly accessed. We have to create objects of the class. So I repeat, for summarization, that Java program contains at least one class, and the class is just like a blueprint or a set of data and methods. And to access the data and methods, we have to create object. How to create object? We will show in the implementations in the subsequent videos how to create objects. But we have to create object. Right, for now we understand that we have to create objects to access the data and methods of the classes. Object oriented programming, a program is organized or oriented around its data. What does it mean? That the program cannot directly play with its data. A program can only access its data only via creating its objects. That is, without creating objects, the data cannot be accessed. That's why it is object oriented. So if we give an analogy that what is class and what is object, I have already said that class is a set of properties. Properties means data and functions. There is a template without any physical existence. Class does not have any physical existence, whereas object is the, you can say that object is also a set of behaviors. That is, object behaviors means the data and the methods, but object has the physical existence. That is, you can say that class is a template, whereas object of that corresponding class has the physical existence, or the object can be treated as a runtime entity containing all the class properties. That is, an object will contain all the variables, all the methods that a class have, but class will not have any physical existence, whereas object has physical existence. If we give an analogy, then you can say, for example, if we say that humanity is a class, then human being is an object. Humanity is a property, it can be treated as a class, whereas human being, it is something with physical existence, real life existence, it is an object. That is, when we create an object, the object will get its memory in the RAM. For example, a class has 5 integer type variables. So in Java, an integer takes 32 bits size. So for 5 variables, it is 160, 32 into 5, 32 multiplied by 5, it results 160 bits. So object will get total 160 bits of memory in the RAM. And also, the last thing, in object oriented programming, the program gets access to control its data. What does it mean? That the data in the program can be controlled. That is, how any other program can also get access to the data. Also, we can say that the data in the program cannot be directly accessed, or even the data in the program cannot be even accessed outside the program. Also, the method can be redefined. Also, the class can be reused using object oriented programming. These are the 3 object oriented properties of a Java: encapsulation, polymorphism, and inheritance. All these things will be discussed in module 1 in the subsequent videos. Next point is that Java is strongly typed. What is it? Strongly typed in the sense that every variable must be declared with a particular data type. That is, if we declare a variable x, it has a corresponding data type, whether it is integer or float, whatever it may be, the data type should be specified. If it is integer, we have to write int x. If it is float, we have to write float x, or we can write also double x. So there are 8 data types in Java, which are byte with 8 bits, short with 16 bit size, int is 32 bits of size, long is 64 bit of size, float is of 32 bit size, double is of 64 bit size, character has 16 bits, Boolean does not have actually it depends on the operating system. The size depends on the operating system. Boolean represents the logical values, true or false values. The first four data types, that is byte, short, int, and long, are for integer variables. The next two, that is float and double, these two data types are used for floating type variables. Character char is used for character type data, and Boolean is for the logical values. Now the last one, platform independent programming language. Java is platform independent. Why it is so? In Java, if we write a code in, suppose our machine is Windows, I am writing a code for Java. Now, if anyone want to execute the code, same code, in Linux operating system or Mac operating system, they can execute it. The programmer who is writing the code in Linux operating system or Mac OS operating system, he or she does not have to change anything in the code. Whereas in C programming, we know that uh, something is different. For example, conio.h, it is used in Windows, but it is not used in Linux. Conio.h in case of C programming. But in Java, whatever you write in Windows platform or in Linux platform, it will run in any operating system. You don't have to bother about your platform. Why it is so? Because Java is interpreted language. Interpreted in the sense that the compiler, Java compiler, first compiles the program, and after compilation, it converts the Java program. Java program is high level language, written in high level language. So after compilation, this high level language is converted into some intermediate language. It is known as bytecode. Bytecode is an intermediate language. So Java compiler converts the high level programming language, that is a Java program, into some intermediate language which is known as bytecode. So bytecode is platform independent. Compiler and bytecode both are platform independent, because the programmer does not have to bother about in which platform he or she is writing the code. The same code will run in every operating system. That is because of the compiler is platform independent. So compiler converts into the Java program into intermediate language which is known as bytecode. Now the bytecode is not executable code. You can share your bytecode. Suppose you are writing the program in Windows platform. After compilation, you will get the bytecode. Java program has extension as .java. For example, in case of C programming, the extension of the program is .c. Here it is .java. Everything in small letter, .java. Now after compilation, you will get the bytecode which is extension is .class. Now you can share your bytecode to your friend who is compatible with Linux operating system. Now in Linux operating system, your friend will download your bytecode and he can execute the bytecode. Now this is the part execution. Now, the compiler only does the conversion part. It can convert the Java programming Java code into bytecode. Now we have to run the code, execute the code. For execution, there is a machine which is actually abstract machine known as JVM, Java Virtual Machine. Java Virtual Machine acts as an interpreter. That is, it interprets the intermediate language. That is, intermediate language means the bytecode. Bytecode is intermediate language. So JVM will interpret the bytecode and convert the bytecode into executable code. This is Java Virtual Machine. Java Virtual Machine is acting like interpreter. It will convert the bytecode into machine executable code, and then you can execute your program. So there are two phases. After compilation, you cannot execute it directly because compilation will result bytecode, and then you have to interpret. That is, on behalf of the programmer, JVM will interpret the bytecode to make it executable. So JVM is the interpreter, Java Virtual Machine. But now the question is that bytecode is platform independent, but whether JVM is also platform independent? No. The answer is no. JVM is not platform independent. JVM should have the knowledge about the hardwares of the of your computer, of your platform, or the configuration of the machine. If JVM is not aware of the configuration of the machine, so JVM cannot convert the bytecode into machine executable code. So JVM is responsible to converting the platform independent bytecode into machine, I am saying machine dependent or machine executable. So the bytecode will be converted into executable form. Now to execute it, the JVM must understand the configuration of the machine. Otherwise, he cannot. That is, the JVM cannot convert it into machine executable code. So JVM should aware of the platform. That is, JVM is platform dependent. Bytecode, till bytecode it is platform independent, but JVM should be platform dependent. And then, so JVM is actually an abstract machine. It has no implementers. It is just theoretical concept. JVM, to make it to provide the runtime environment, JRE is used. Java runtime environment is used. Java runtime environment is nothing but the implementation of JVM with the Java libraries. This is JRE, Java runtime environment. And Java runtime environment, along with Java's compiler and the Java files, other files or debugging tools, is collectively known as JDK. JRE plus the other tools like compiler tools, debugging tools, known as JDK, Java Development Kit. Java Development Kit is the entire software, actual software. So in your machine you have to install JDK. In JDK you will find JRE, Java C, Java. Java is actually to execute the Java program, everything. So so let's have a look of the history of Java. Original name of Java was Oak, and it was developed in 1991 by James Gosling, who was working at that time at Sun Microsystems. The first appearance was in 1995. The beta version of Java was released, and the complete version, entire JDK version, the software JDK 1.0 was released in 1996. Now the current version is JDK 1.14. It has been released in this year 2020, March 17. In this year also another version is expected to be released, that is the Java 1.15, the next version. Actually what happens that from 2010 Oracle took the acquisition of Sun Microsystems, and from 2016 onwards Oracle has taken the decision that in every year 2 Java versions will have to be released. So this year another version, next version 1.15 is expected to release on September or October. So in summary, these are the features of Java: object oriented, platform independent, strongly typed, multi-threaded. This will be discussed, multi-threading will be discussed in module 2. This is used for multitasking purpose. Dynamic in the sense that Java is portable, bytecode can be executed in any operating system, secured. Actually JVM provides the runtime environment for Java program to run, and Java program is not being allowed to access the machine's environment. It is actually executed in the Java runtime environment provided by JDK. That's why it is secured. Java program cannot get access the machine environment. And the efficient memory management can be done using garbage collection provided by JVM. In the next video, we will write our first Java program, first using command prompt and then using NetBeans. Thank you for watching the video.